Into chapter 15 here, talking about amines and amines. All right. So this is our last chapter on organic chemistry. When we get to chapter 16, it's going to be on biochemistry. So 16, 17, 18, and 20 are chapters over biochemistry. Okay. So basically, we're going to take all these 6 chapters of organic chemistry and we're going to try to apply them to the organic chemistry, okay, that we're going to learn about. All right, so our last organic group are the amines and the amines. So what is an amine? Amines are derivatives of ammonia. Ammonia is a nitrogen that has 3 hydrogens bonded to it with 1 lone pair on its structure. So this is ammonia. Okay, people use it for cleaning stuff, or they use it in fertilizer. It has a lot of industrial uses. Okay, but a lot of these amines are going to have similar physical characteristics and structural characteristics as would ammonia. Okay, so these amines are organic bases. So we have carboxylic acids, right? And we have molecules that are bases. So what makes a base a base? So let's look at ammonia really quick. Ammonia is a base. Why? By definition, a base is a molecule that will accept a hydrogen. Okay? So if I have ammonia, let's say plus water, okay? Ammonia will take a hydrogen from water and it will become ammonium. And what's left over after it grabs that hydrogen off of water is hydroxide. If you have hydroxide left over, then your solution is going to be basic, because hydroxide is the base ion. If you have H plus left over, then your solution will be acidic, because H plus is the acid ion. Okay, so the carboxylic acids all dissociated hydrogens, and so you had hydrogens free in solution, H pluses, that made them acidic. But these bases are going to grab a hydrogen off of water, and they're going to have OH minus left over in solution, making them bases. Okay, so wherever you see nitrogens in organic compounds, most often means that that molecule is basic. It is a basic molecule because it will accomplish this kind of chemistry. Okay? Oh, and this is a positive conjugate. So this is the base, and this is the conjugate acid of that base. Okay? So this is the conjugate of ammonia, ammonium. So you can see that if I just slap a carbon chain onto this nitrogen, I still have very similar properties to this ammonia molecule that we just looked at. Okay. They're all going to be trigonal pyramidal. They have that lone pair on the top. Okay. So this ammonia to the amines, you can see that they all have that trigonal pyramidal structure. Classification of an amine. Once again, we're going to do primary, secondary, and tertiary. Primary amine would be an amine that a nitrogen that has how many carbons on it? If it's a primary amine, it has how many carbons attached to it? Same as all the other things that we've classified primary, secondary, and tertiary. There's 1 carbon on it. Okay, so how many carbons are going to be attached to the nitrogen? 1. How many carbons will be attached if it's a secondary amine? 2. How many carbons are going to be attached if it's a tertiary amine? 3. Okay, that same thing with the primary, secondary, or tertiary carbon or alcohol. Okay, it's how many other carbons are attached to the group. So here's ammonia, no carbons on it, just call it ammonia. It doesn't have a classification of primary, secondary, or tertiary. But then here we have this methanamine with a methyl group on it, just 1 carbon attached. That's a primary amine. If I put 2 carbons on there, that's a secondary. Okay, if I put 1, 2, 3, that's a tertiary. So amines form hydrogen bonds because there are 3 elements on the periodic table that can hydrogen bond. What are they? Nitrogen, oxygen, and fluorine. But they also have to be covalently bonded to a what? Okay, so if I have a ketone, let's say, does it hydrogen bond? No. If I have an alcohol, does it hydrogen bond? Because the oxygen is covalently bonded to a hydrogen. So the requirement to hydrogen bond is that your hydrogen bonding element, nitrogen, oxygen, or fluorine, has to be covalently bonded to a hydrogen. Okay? Then that molecule has hydrogen bonding capabilities. Now, this oxygen has secondary hydrogen bonding capabilities. It can form a hydrogen bond with something that hydrogen bonds. So it could form a hydrogen bond with water. Oops. Because water is covalently bonded to hydrogens. The oxygen of water is covalently bonded to hydrogens. Okay? So this has a secondary hydrogen bond, but alcohols have primary hydrogen bonding capabilities. Okay, we're going to pause it there.